Good morning, guys. Today we are going to start a new topic. New topic means that is we have discussed about trusses. Now today we are going to solve some problems on trusses. Okay, some problems on trusses. To solve problem on trusses, just observe. I think basically I derived two derivations up to now. See, if you want to solve any problem on trusses, something you want to remember. One is you know how to represent an element. Element minimum requirement is element should consist of two nodes. Okay, for a truss element, two nodes should be there, and you know what are the displacements in trusses. If you take only two nodes, each node you have two displacements. One is horizontal displacement, one is vertical displacement. In that matter, we are going to get Q1, Q2 at node 1 and Q3, Q4 at node 2. That means Q1 and Q3 are called as a horizontal displacements, and Q2 and Q4 will be called as a vertical displacements. Okay. Now, apart from this, what do you want to remember? You remember elemental stiffness matrix. What is elemental stiffness matrix for truss? Already we derived AE by LE, L square, LM, M square, minus L square, minus LM, minus M square, L square, minus L square, minus LM, L square, LM, minus M square, LM, M square. I know, I think I told you already how to remember this. Next, after this, what is the next thing you have to remember? Load vector. What are the load vectors? Generally, it will come. We know that what is load vector means. There are three types of loads can be applied on a structural member: body force, traction force, and your one more load is point load. But for this problem, already we have stated certain assumptions. Because of that, what we can get only your point load vectors. Only point load vector, because self weight is neglected and loads applied will be only applied at a particular joints only. Because of this, traction force is neglected, body force is neglected. You only get a point load. Because of that, what is your direct global force vector will be directly equal to your point load vector. Now, what is point load vector? Here you should see that point load vector means you cannot use only single element. You should use two components at each node. One is called horizontal force component and vertical force component. Because of that, I am going to write here totally four components for a single element. That is P1, P2, P3, P4. The reason is very simple. What is the horizontal force acting at node 1? Same vertical force acting at node 1. P3, P4 means horizontal force acting at node 2, vertical force acting at node 2. That means horizontal component and vertical component. And then stress in element, how to determine? We know that BQ is equal to strain. You should multiply with E. You can get EBQ, that is called your stress component. You know what is the formula for it? E by LE into minus L minus M, LM, Q1, Q2, Q3, Q4. This already we have discussed. Now, after discussing this, now I am going with the first problem. Okay, just read the problem number 1. What is the problem number 1? For the pin jointed configuration shown in figure, determine the global stiffness matrix, displacement at each node, stress in each element, and one more is stress in each element and reaction at the support. Consider Young's modulus will be equal to 200 GPa. Now this is what the figure given. See, 500 mm horizontal vertical distance 750 mm. Then area is given. Area of the element is one element is 1200 mm square. Another element is 1000 mm square. Now, if you observe this, how many elements will be there in this figure? First, you should understand. And one more thing you should first understand is always you should represent your truss in a first quadrant. First quadrant means you want both x and y should be positive. Keep always both x and y should be positive. Where x and y should be positive, it will be in your first quadrant. Represent in your first quadrant. Say represent in first quadrant means, that means my x-axis will be like this. Okay, this is x-axis, this is y-axis. Okay, now if you take x and y axis, then which node I want to start from? Which is the first node in this figure? So because of I want it in first quadrant, I will keep this will be first node, node 1, this will be node 2, and this will be node 3. That means node 1, node 2, node 3. That means which is first element now? This is your element number 1, and this will be your element number 2. That means how many number of elements in a truss given? 2 elements are there, element number 1 and element number 2. Now what is the length given? 750 mm, 500 mm. Now apart from this, what is the data given? A is given, A1, that is area of first element is 1200 mm square, area of second element is 1000 mm square, Young's modulus is given, that is 200 GPa. Apart from this, there is a vertical load is acting at node 2, that is 50 kilonewton. Then you should see that how many displacement I can get for this problem. So if you observe, I can get a displacement here, node 1, how many displacements? Q1, Q2 is the displacement I can get here. Then what are the displacement I get? I can get displacement here. What is the displacement I can get? Q3 and Q4 are the displacement at this particular node. Then what is the displacement I will get here is one more Q5, Q6. The meaning is if 3 nodes are there, totally 6 displacement. Each node, one horizontal displacement, one vertical displacement. Horizontal displacement, vertical displacement. Horizontal displacement, vertical displacement. Why horizontal displacement, vertical displacement? Because it is in global coordinate system, we should determine the solution. Global coordinate system means for a truss at each node, how many displacement you get for a global displacement? So global coordinate system, 2 displacement, one horizontal, one vertical. If you take local coordinate system, how many displacement? Only one. If I take in that manner, q1 dash, q2 dash and q3 dash. Or this, but your local displacements are not required. You only concentrate more on your global displacements, q1, q2, q3, q4, q5, q6. Now after this, what is the next step? Next step is, so if you want to solve a problem, you want to determine elemental stiffness matrix, correct? Elemental stiffness matrix is determined. See, before going to determine your elemental stiffness matrix, certain data has to be calculated. So for that, just read what is your elemental stiffness matrix. If you take your elemental stiffness matrix for any truss element, what is elemental stiffness matrix for truss element? Say I am not doing this. First I am writing elemental stiffness matrix. What is this elemental stiffness matrix? AE by LE, L square, LM minus L square minus LM. This one LM, M square, LM, that is minus M square. Similarly, minus L square minus LM minus M square, L square, LM, M square. I told you how to remember this. 1 minus 1 minus 1 1. Okay. So if you observe how many parameters is required for you, area is required, Young's modulus is required, length of the element is required, L and M is required. Correct. See, if you want to determine this, see, before going to determine the elemental stiffness matrix, I required L length of the element, L, M. Because length of the element is not given for this problem. See, you should determine, in a trusses, you should determine the length of the element and direction cosines. To determine that, for that I want to list certain data initially. What is that data I want to list it initially? First, take the two tables. Step one is, take first nodal coordinate table. What is the nodal coordinate table? That means our nodal connectivity table. See how many node numbers are there? I have 3 nodes, 1, 2 and 3. I have 3 nodes, node 1, node 2, node 3. Now see what are the value of x coordinate and y coordinate at each node. See, if I take this node, what is the x coordinate here? 0, 0, because I am taking that as a first node. It's 0, 0. That means my x coordinate is 0 here, y coordinate is 0 here. That means I have written xy axis just for representing your first coordinate. That means your x and y will be actually starts from this particular point. X is thus, y is thus. That means x coordinate is 0, y coordinate is 0. Just for representation purpose, I have written the axis here. That's it. Over. Then, what is the next? Node 2. Node 2, if you come to node 2, what is the x coordinate? From 0, it has traveled up to 750 in x direction. Then it has traveled up to 500 mm in y direction. That means, what is my x coordinate and y coordinates at node 2? 750 and 500. 750 and 500. What is this here? 750, 500 is at node 2. Now similarly at node 3, what is the value? Node 3, if you come here, x is 0, y is 500, because height 500 is there, x will be 0. That means 0, 500. 0, 500. Now similarly, retrace the data here once again. Now this is nodal connectivity, but what is required for me? Length of the element. That means element table is very, very important compared to your nodal table. That means I require length of the table. What is the length of this one? Elements? How many number of elements are there? 2 elements. This is one, this is one. This is first one, and one more is second one. This is element number 1. This is element number 2. Now take first element number 1. What is element number 1? Element number 1, it asks you what is the initial node and final node. What is initial node and final node? See, this will be your initial node. This will be your final node. Always you remember, it should be in this manner, cyclic manner. Okay, that means this is initial node. This is your final node. That means initial node is what? Initial node is node 1. What is the coordinate at that particular point? 0, 0. What is final node? Final node is at node 2. What is that value? 750, 500. Similarly, come to know element number 2. Element number 2 means, which is element number 2? 2 to 3 is element number 2. Which is initial node for element number 2? 2 is your initial node. What is that value? 750, 500. What is your final node? Node 3. What is the value for that? Value for node 3 is, what is node 3 value? 0, 500. 0, 500. Now, I want to calculate length of the element L and M. See, to calculate length of the element L and M, we know the formula. What is that formula? Just observe here. LE is equals to, what is LE? LE is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Have you remembered this? I think I had shown this. x2 minus x1 whole square plus y2 minus y1 whole square. Now, what is x2 minus x1 and y2 minus y1? Very simple. See, one initial node and final node. See, always initial node will be x1, y1. Final node will be x2, y2 for element. See, for this element, which is initial node? 1 is initial node, final node is 2. Now calculate what is your length of element. Length of element will be equal to, what is x2? 750. This is for only for element number 1. 750 minus 0 whole square plus what is y2? y2 is 500 minus 0 whole square. Just check it. What is the answer? 750 square plus 500 square divided by square root of answer. What is that? That length of the element is 901.38. 901.38 mm is the length of the element. Now I got length of the element, but not enough. What is required for me? L is required. What is L? x2 minus x1 divided by length of the element. What is x2 minus x1? 750 minus 0 divided by 901.38. What is the answer? Just check it. 750 divided by 901.38. What is the answer? Answer is 0.83. 0.83. Now you got L. How to calculate M? M we know that M means sin theta. What is sin theta? y2 minus y1 divided by length of the element. This already I think explained. y2 minus y1 is what? 500 minus 0 divided by 901.38. What is the answer? What is the answer? 500 divided by 901.38. What is the answer? 0.55. 0.55. If you have any doubt, you can check once again. 500 minus 0 divided by this. Now you got L, you got M. If you want, you can calculate what is L square, what is L square, what is M square, what is LM. You can calculate what is L square. Just make it what is square of 0.83 square. 0.83 square is 0.68. 0.688. Then M square is 0.55 square. What is the answer? 0.3042. 0.302. Okay, you want LM. LM means multiply 0.83 into 0.55 minus 0.456. 0.456. This is how you should calculate your complete data required for your element number 1. That means now you represent all the data in your previous element table. What is that element table? Right, your element connectivity table, all the data. What is the data required? Just observe. What is length of the element? 901.38. What is this? 0.83. 0.55. See why I am writing this? See, this will be helpful in further steps. Every time you don't want to calculate what is L and M, because if you want to calculate stress, you require L and M. Correct? If you want to calculate strain, you require L and M. Because of this, you don't want to avoid this. Length of the element is also required. In here itself, you can calculate what is LE, what is L, what is M. Or this. Now, same thing repeat for second element. Same thing repeat for second element. See, what is second element? Now observe which is initial node for second element, because it is starting from 2 to 3. Element is 2 to 3. That means it is in cyclic nature. 2 to 3. Where is 2 to 3 means? Now which is initial node? x1, y1. That is your 2 will be your initial node. 3 will be your final node. Use same procedure. Length of the element will be equal to same formula. x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square. What is x2 minus x1? Just observe which is x2. x2 is now 0. 0 minus 750 whole square plus what is y2? y2 is 500. 500 minus 500 whole square. Now what is the answer you are going to get? You are going to get length of the element will be equal to 750. Why? Because 500 cancel, 750 square, it will be 750. Now length of the element, you got it. Similarly, repeat how to calculate L. L is equal to what? x2 minus x1 divided by length of the element. What is x2? x2 is 0. What is next? 750 divided by 750. What is the answer? It is minus 1. Be careful about that. Minus 1. Okay, next what is M? M how to calculate? y2 minus y1 divided by length of the element. What is y2? 500 minus 500 divided by 750. What is the answer? It is 0. Now you got L, M. What is unknown? What is required for our further? L square. What is L square now? Minus 1 square means minus 1 into minus 1 plus 1. What is M square? 0. What is LM? LM is equals to minus 1. Sorry, minus 1 into 0, 0. Minus 1 into 0, 0. Now you got L square, M square and LM. This is how you should calculate it. Now once again represent all the data obtained in the second element. What is your second element? 750 is the length. L equals to how much? Minus 1. M equals to 0. Okay. This is what your element connectivity table. This is your nodal coordinate tables. In some textbooks you can observe that even L square, LM, everything will be written here itself. That also you can write it. Okay, to minimize number of steps. But how to calculate your L, M and L square, LE is very, very important. L, M and LE. You know why L is equals x2 minus x1 cos theta? I think I explained in the previous previous video. Okay. Now, come to now calculating your element stiffness matrix, elemental stiffness matrix. Now I am calculating for first element. Write it KE1. What is A? A is 1200. What is E? 2 into 10 power 5 because 200 GPa is given. Divide length of the element is how much? Calculated 901.38. Okay. What is L square? L square already we have calculated. 0.688 is there. If you want, you can minimize it. Only 0.68 you can write it, or you can keep it 0.68 only, no problem. LM is 0.456. First finish this. Then 0.456. What is M square? M square is 0.302. Now, if you know this 4, now retrace this. Okay, 0.688, 0.456. Okay, then minus 0.456 minus, sorry, 0.302, that is minus. Now once again write it, 0.688 minus 0.456 minus 0.456, okay, minus 0.302. Now similarly 0.688, 0.456, 0.456 and minus 0.302, not minus, this is plus. Okay, now you got it. Now if you want, what I want to make it, KE1 I require, what I will keep it, 10 power 5 I will keep it outside, remaining all the values I will write inside. To write this, I will calculate first. How to calculate? What is my value? 1200 into 2, that is 2400 divided by 901.38. 901.38 means 2.66 I am going to get. 2.66. Now see here, 2.66 into 0.688. 2.68 into 0.68, that is 1.83. 1.83. Now here also what I am going to 0.456 into 2.66. First I will finish this. 1.21. 1.21 means this also 1.21 because LM. Next 0.302. 0.302 into, what is that value? 2.66. That's that 2400 divided by 901.38. Yeah, 2.66 into 0.302. You check it. 0.80. 0.80 you are going to get. Now this is this value what it means, remaining minus 1.21 minus 1.21 0.80. Next minus 1.83 minus 1.21 minus 1.21 minus 0.80. Similarly 1.83 1.83 1.21 1.21 0.80. Now this got it. This you got it. K1. Now what are the node numbers for this? Because it is element number 1. Element number 1, what is the node numbers? 1, 2, 3, 4. 1, 2, 3, 4. You ask me why 1, 2, 3, 4? Because element number 1 consisting of how many displacement? 2 displacement. What is the displacement you represent? Q1, Q2. What is element number 2? Q3 and Q4. This is how you should calculate your element number 1. Now repeat same step for element number 2. Element number 2. What is your element number 2? Now, see, I already know what is your elemental stiffness matrix for element number 2. Ke is equals to, that means K2 directly I am writing now. What is the area of second element? 1000. What is the length of the Young's modulus? 2 into 10 power 5. Now, what is your length of the element for second element? Second element length of the element is 750 calculated. Then, what is required for you? L square LM. See, just observe what is the L square LM for second element. L square is 1, M square is 0, LM is 0. That means only L square you have, remaining values are 0, 0, correct? That means 1, 0, correct? Because L square is 1, 0, 0, 0, 0. You may ask me, L square is plus 1. Sorry, L square is how much? Yeah, L is minus 1, L square is plus 1. That means 1, 0, 0, 0. Now minus 1, 0, 0, 0. Minus 1, 0, 0, 0. What is this value? 1, 0, 0, 0. Now calculate what is exact values of it. Keep 10 power 5 outside. Okay, now calculate it. What do you want to calculate? 2000 divided by 750. 2000 divided by 750. 2.66 it will come. 2.66. That means 2.66. 2.66. 0 minus 2.66. 0. 0, 0, 0, 0. Minus 2.66. 0. 2.66. 0, 0, 0, 0, 0. Now just observe what is the number of your nodes here. 2 and 3. That means displacements are 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. This is how you should calculate your element number 2. Now I calculate element number 1 and element number 2 stiffness matrix. What is the next thing? The global stiffness matrix. Now how to calculate your global stiffness matrix? We know that what is global stiffness matrix means? K. K is equals to what? K1 plus K2. Ke1 plus Ke2. Now if you observe Ke1 and Ke2, how many values of rows are there? How many values of columns are there? That means 1, 2, 3, 4 in first element, second element 3, 4, 5, 6. Now what is the meaning of it? That means I am going to get a 6 values in a row wise as well as 6 values in a column wise. 6 values in row wise as well as 6 values in column wise. Because of this, what I want to make it, what is my global matrix should be? Global matrix should be 6 cross 6. Because of 3 nodes, each node I am going to get a displacement horizontal, vertical. If you make it, what is the total continuum displacement you are getting? 6 displacements. Now the order of the matrix should be 6 cross 6. Now how to determine that 6 cross 6 matrix? Now write it. K equals to what is this one? 10 power 5 is common. Now write a matrix of order 6 cross 6. Now first here represent 1, 2, 3, 4, 5, 6. Similarly 1, 2, 3, 4, 5, 6. Now check what are the values of 1, 2. See what are the values you got it for 1, 2. 1 cross 1, just observe 1 cross 1 is 1.83. 1 cross 1 is 1.83. 2 cross 1 is 1.21. Now write it. 1.83, 1.21. Then 3 cross 1. 3 cross 1 is there, but in this one there is no 3 cross 1. 3 cross 1 is also it is there. Minus 1.83. Minus 1.83. Minus 1.21. 1.83 minus 1.21. Then 5, 6 is there. Related to 1, there is no 5, 6, 0, 0. Now first row should be equals to first column. Repeat it as minus 1.83 minus 1.21 0, 0. Now what is required? 2, 2. Check 2, 2. 2, 2 is 0.80. 2, 2 is there in this one? No. 0.80. 0.80. 2, 2 is 0.80. Next 3, 2 minus 1.21 minus 0.80. And here also 5, 2 and 6, 2 will not be there. So correct. Now come to 2, 3. 2, 3 is there. 2, 3. 2, 3 is minus 1.21. 2, 3 is minus 1.21. Okay. Then 4, 3. 2, 4. 2, 4 is minus 0.80. 2, 4 is minus 0.80. That means here this will be finished. Now come to 3, 4. See, you should understand exactly where connectivity is possible. See, connectivity is possible only at node 2. Because node 2 is a connectivity between second element and first element. Because of this, always remember at node 2 there should be 2 values should be added. Node 2 means what are the displacement? Q3 and Q4. That means 3, 3 and 4, 4. You should have addition of values. Now based on that concept, now also if you observe here, 3, 3 is 1.83. If you come to this one, 3, 3 is there. What is the value? 1.83 plus 2.66. 1.83 plus 2.66. Now next value is 4, 3. Just observe 4, 3. 4, 3 is how much? 1.21. 4, 3 is 1.21. 4, 3 is 1.21 from this. Now if you observe 4, 3 is there. 4, 3 is there. That is 0. That means 1.21 here. Now that means this will be also be 1.2 because third row should be equals third column. Now come to 4, 4. What is 4, 4? Just observe 4, 4. 4, 4 is 0.80. 0.80. 4, 4 is 0.80. Now here we have two values 0.80 plus 0. Because 4, 4 in this one is 0. Next come to 5, 3. 5, 3 minus 2.66, 0. Then 0, 0. Why? Because 5, 6 will not be there. Because that element is consisting of only 1, 2, 3, 4. This is 3, 4, 5, 6. Now rows are this one finished. Now come to this. See there is no relation between 3 and 5. Because 1, 2, 3, 4 only it have. Because of this directly write 3, 5 and 5, 6. That 3, 5 and 5, 6 I'll write. So what is 3, 5? Minus 2.66. This value. Then 4, 5, 0, 5, 5, 2.66 and 0. Then last row 0, 0, 0, 0. Why 0, 0? Because if you observe, what is 3, 6? 3, 6 is 0, 4, 6 is 0, 5, 6 is 0, 6, 6 is 0. This is called your global stiffness matrix. How to formulate your global stiffness matrix? See, after formulating your global stiffness matrix, next step is, what is the next step? Apply your, see after determining this, what is the next step? Global force vector and displacement vector. What is global force vector and displacement vector? What is your global force vector and displacement vector? See, first displacement vector if you take it. Displacement vector. What is the displacement vector? Directly write displacement vector Q is equals to, how many displacements will be there? Total is 6 because of 3 nodes. Q1, Q2, Q3, Q4, Q5 and Q6. Now I am writing transpose. Generally I am not written in the form of a column, I written in the form of a row, because of that I kept in a transpose. Similarly, what is global force vector? Force vector means F. I told you what is this? It is only point load vector. Because of this, FE plus TE plus PE, this is 0, this is 0 and this is 0. Sorry, only point load will be there. That means F will be equal to, now if you take it in a horizontal manner only, what is the, just observe now, you observe your problem now. Observe your problem now. What is the force acting at node 1? Horizontal any force is acting, vertical any force is acting? No. Because of this, see the force 0 and 0, because there is no F1 and F2, because horizontal force is 0, vertical force is 0. If you go to node 2, observe node 2. Any horizontal force is acting? No. That means horizontal force is not there. 0. Vertical force acting. What is that? 50 kilonewton. How it is acting? Downwards or upward? Downwards. That means F3 is 0. That means F3 is 0, but F4 is equals to minus 50,000. Why minus 15,000? Minus 50,000 because downwards. Now, at node 3, if you observe your figure, at node 3, any force is acting? No. That means horizontal force is also 0, vertical force is also 0. See, now observe. Here, there is no horizontal force, but vertical force acting. I submitted in the form of a vertical force. That means first one is horizontal force at node 1, vertical force at node 1. Horizontal force at node 2, vertical force at node 2. Horizontal force at node 3, vertical force at node 3. This is how you should determine your load vector, point load vectors. Sir, only point load is acting. This is called your global force vector. Now, you know stiffness matrix, global stiffness matrix, you know displacement vector, you know your F also, correct? F load vector. Now substitute all the values. Now I am writing K. What is my equilibrium equation? KQ is equals to F. Now write it. What is the order of the matrix? 6 cross 6. First one is this value. What is that value? 1.83, 1.21 minus 1.83. Okay. Minus 1.2100. Okay. Now 1.21. Then 0.80. Already I calculate this. Minus 1.21. Okay. Minus 0.80. What is next one? 0, 0. Okay. Next. Minus 1.83. Minus 1.21. Now there is addition of values here. 1.83 plus 2.66. It is 4.49. 4.49. Okay. Then 1.21. 1.21. Okay. Then what is this one? Minus 2.66. 0. Okay. Then minus 1.21. Minus 0.80. 1.21. Then 0.80. 0.80. Then 0, 0. Okay. Then write it here. 0, 0 minus 2.66. Okay. 0, 2.66. 0. Then 0, 0, 0, 0, 0, 0. This is your what? Your K calculated. Then Q1, Q2, Q3, Q4, Q5 and Q6. Then after this, if you come to forces, 0, 0, 0 minus 50,000. Then 0, 0. This is what your equilibrium equation for continuum. K into Q is equals to F. This is K, this is Q, and this is F. This is how you calculate it. Then after this, what is the next one? Boundary condition. What is boundary condition you should apply? Say use only elimination method. In this, I think we are not going to use any penalty method problems. Maximum we are going to apply elimination method. Elimination method. Apply your elimination method. What is your elimination method? Says that wherever the fixed node is there, eliminate that corresponding row and corresponding column. Now, what are the nodes fixed? See, fixed nodes are, what are the fixed nodes? Fixed nodes is node 1 and node 3. Node 1 and node 3. Now, node 1 and node 3 means, node 1, what is the corresponding row and column? What is the corresponding displacement? Node 1, corresponding displacements are what? Corresponding displacements are Q1 and Q2. That means both Q1 is equals to 0, Q2 equals to 0. That means which are the corresponding rows? First row and first column, second row and second column. Eliminate first row, first column. Eliminate second row, second column, because it is related to this. Similarly, node 3 is also fixed. Node 3 is also fixed. What are the corresponding displacements? Q5 and Q6. That means Q5 and Q6 will be equal to 0. Now what are the corresponding rows and columns? Eliminate fifth row, fifth column, which is fifth column, this is fifth column. Okay, similarly eliminate sixth row and sixth column. Now whatever remaining is there, write the remaining value, that is 10 power 5. 10 power 5, what is the value? 4.49, 4.49, 1.21, next 1.21, 0.80, 0.80 into, what is the displacement? Q3, Q4 is equals to 0 minus 50,000. 0 minus 50,000. Now solve this. So if you solve this, I am going to get 4.49 into Q3 plus 1.21 into Q4 is equals to 0 because divided by 10 power 5. This is the 1. Okay, next 1.21 into Q3 plus 0.80 into Q4 divided by minus 50,000 divided by 10 power 5. See, from this equation, you are going to get Q3 is equals to, just observe here, Q3 is equals to 1.21 divided by 4.49. Q3 is equals to 1.21. 1.21 divided by 4.49, that is minus 0.269 Q4. You are going to get minus 0.269 Q4. See, now substitute this value in this equation. What is that? 1.21. Just observe now. 1.21 into minus 0.2 minus 0.269 minus 0.269 into Q4 plus 0.80 into Q4 is equals to minus 50,000 divided by 10 power 5. The answer is minus 0.5. Minus 0.5. Now if you solve this, you are going to get Q4. Q4 is, I will just calculate, 1.21 into minus 0.269 plus 0.80, that is 0.474 minus 0.5 divided by minus 0.474. The answer is minus 1.05. We are going to get minus 1.054, that is millimeter is Q4, and Q3 is equals to, just repeat, Q3 is equals to, what is Q3? Q3 is equals to minus 0.269 into, what is Q4? We got it, that is minus 1.054 minus 1.054. The answer is 0.283. 0.283 millimeter. Just if you can once again, minus 0.269 Q4, that is minus 0.269 into minus, yeah, right. This is what the values you got it for your Q3 and Q4. Q3 and Q4 is the values. Now if you got Q3 and Q4, now how to calculate your stresses and strain? Now we know that what is strain? Epsilon 1, because how many elements? 2 elements. Epsilon equals to BQ. Okay, what is B? E by LE, sorry, not E by LE, 1 by LE minus L minus M, L, M into Q1, Q2, Q3, Q4. You know why Q1, Q2, Q3, Q4? Because element number 1 consists of node 1 and 2. What are the displacements of node 1 and 2? Q1, Q2, Q3, Q4. Now, 1 by LE, what is the length of the element? 901.38 is the length of the element. What is minus L? What is L value for this? L value for this is minus 0.83. That is 0.83 minus 0.83, it will become minus 0.55, 0.83, 0.55. Now what is Q1, Q2, Q3? Q1 is 0, Q2 is 0, Q3 is 0.283 and minus 1.054. If you calculate what is the value you are going to get, just check it. This into 0, 0, that is 0.83 into 0.283 plus, okay, 0.55 into minus 1.054, okay, divided by 901.38. You are going to get minus 3.82 into 10 power minus 4. This is your strain value, that is epsilon 1. Now how to calculate stress? Just make it sigma 1 equals to E into BQ. What is E? 2 into 10 power 5 into epsilon 1. What is the answer? Just multiply 2 into 10 power 5 into minus 3.82 into 10 power minus 4. You are going to get minus 76.4 Newton per mm square. This is what is stress. You are going to get it at that particular point, stress. Similarly, repeat epsilon 2. How to calculate epsilon 2? Same BQ 1 by LE minus L minus M, L, M. Okay, L, M. What are the displacements now? Q3, Q4, Q5, Q6. Now, what is 1 by LE means? 1 by 750. What is L? L is minus 1 means it will become minus 1 plus 1. Minus 1, it will become plus 1. Minus M is 0. L minus 1, 0. Then what are the displacements? 0.283 minus 0.1054. Okay, 0 and 0. 0 and 0. Just calculate it. What you are going to get? 0.283 into 1 divided by 750. What is the answer you are going to get? 3.77. 3.77 into 10 power minus 4 is the strain value you are going to get. Stress will be just multiplying small modulus, that is into 2 into 10 power 5. 2 into 10 power 5, you are going to get 75.46. 75.46 Newton per mm square. This is how you should calculate your stress value. Stress value in your element number 1, stress value in element number 1, and stress value in element number 2. Okay, this is strain in element number 2, element number 1. Okay, now reaction. How to calculate your reaction? Take your eliminated rows. What are the eliminated rows? See, just observe what are the eliminated rows. Eliminate 1, 2, 5 and 6. Now if you take n 1, 2, 5, 6, first I will take it R1. Just I will take R1 directly. I will take from that eliminated row. R1 is equals to 10 power 5, 1.83 into Q1 plus same formula. Okay, same formula. 1.83 into Q1, 1.21 into Q2 plus what is this? Minus 1.83. Minus 1.83 into Q3 plus minus 1.21 into Q4 plus 0 into Q5 plus 0 into Q6 minus F1. See, this is same procedure of what you did in your bar elements. Okay. Now if you take this, R1 is equals to, see, Q1 is 0, Q2 is 0, then Q5 is 0, Q6 is 0, F1 is 0. What you are going to get the answer? Just observe, minus 1.83. 1.83 into what is Q3? Q3 is 0.283 plus, what is the next one? Minus 1.21 into, what is the value of for this one? Minus 1.054 into 10 power 5 into 10 power 5. 75.74 kilonewton is what you are going to get at R1. 75.74. Now this is R1 value. Similarly, if you want to calculate at R2, now repeat same thing, 10 power 5. Just write your second row value, that is 1.21 into Q1, 0.80 into Q2, then minus 1.21 into Q3, minus 0.80 into Q4, 0 into Q5, plus 0 into Q6, then minus F2. F2 is 0 directly, this is 0, this is 0 because all the values are Q1, Q2, Q4. This is 0, this is 0. Now what is the values left? R2 is equals to, just observe the values, minus 1.21 into what is the value of Q3? Q3 is how much? 0.283 plus minus 0.80 into what is the value of Q4? Q4 is minus 1.054, minus 1.054. Okay, just observe, into 10 power 5, 10 power 5, that is 50.07 kilonewton, 50.07 kilonewton, that is plus 50.07 kilonewton. This is what you obtained. R5. Now go to R5. What is R5? Just 10 power 5, same thing, 0 into Q1, 0 into Q2, minus 2.66 into Q3, plus 0 into Q4, plus 2.66 into Q5, plus 0 into Q6, minus F5. F5, I think that the no force is there. This is 0, this is 0, 0 into anything is 0, 0 and 0. Only left with what? Minus 2.66. What is that? Minus 2.66 into 10 power 5 into, what is the value? Q3, 0.283. 0.283. I think you're going to get minus 75.278 kilonewton. Just observe, this and this will cancel. Only R2 will be there. That is what we applied. Minus 50 you applied. Now come to R6. R6, I directly return 0 Newton. The reason is very simple. If you just shift it here, see, what is row 6? Eliminated row, all are 0. 0 into anything is 0. Because of that, directly I am writing R6 will be equal to 0 Newton. See, this is how you should solve a truss problem. See, this is how you should solve a truss problem. Simply, first you should take your figure. From that, write your nodal coordinate table, element connectivity table. Then after element connectivity table, you should know how to determine your L square, LE, LM. Every value is required for that element. Similarly, LE, LM for second element. Then after that, elemental stiffness matrix. Okay, elemental stiffness matrix, global stiffness matrix formulation. Then after global stiffness formulation, you know same procedure. See, procedure is almost similar to your bar element. Procedure is almost similar to your bar element. Only thing is your matrix size will change, because here you know that if you take a single element, you are going to get 4 displacements. Each node 2 displacement, because it becomes 4 displacement. In bar, only you get 2 displacement in element. That is 1-dimensional element. This is 2-dimensional element. This is what the procedure for the problem. Thank you.